So let's look at another integral here. This time we've got a definite integral from 1 to e squared of square root 1 plus ln x over x dx. So, well, the bottom here, the top is not the derivative of the bottom function. However, I do see a function and its derivative here. Derivative of ln x is 1 over x dx, well, the differential, and I see my x in the denominator. So my first thought here would be to let u equal ln of x, and then your du would equal 1 over x dx. And then we would go ahead and start changing this integral over. So we'd have square root, here's our u, so on top we'd have square root 1 plus u. And then dx over x is the same as 1 over x dx, so that's going to be our du. Okay, and then I look at this and I'm like, square root of 1 plus u, that's a function to a power. We would have to do another substitution to evaluate that. So that makes me think that maybe there's an easier substitution to use here. And in fact, instead of log x, you want to include the 1 in there. So let's do this. Instead of ln of x, let's let our u be 1 plus ln of x. So then this whole inside, that's your u. So this will now not be square root of 1 plus u, but it'll just be square root of u. And that's going to be an easier integral to deal with here. So square root of u du. So if you do your substitution and then it looks like you might have to do another substitution to work it out, then go back and look and see if there's a u substitution that'll simplify your integral more. And then the other thing we need to do is change our limits of integration from x's to u values. So if x is equal to 1, then our u is going to be 1 plus ln of 1, right? Take that x equal 1 and plug it in here. And log of 1 is 0, so this is 1 plus 0, which is 1. So that is a 1 there. And then x equals e squared. So we plug that in to our u equation. So you get 1 plus natural log of e squared. And then ln and e cancel by cancellation laws. So this is just 1 plus 2, which is 3. So now we're integrating square root of u from 1 to 3. Well, that's not a hard integral. That's just the integral from 1 to 3 of u to the 1/2 power du. And that's just power rule, right? Raise your exponent. So u to the 1/2 plus 1, so that would be 3/2. And then divide by your new exponent. So division by 3/2 is the same as multiply by 2/3. And then we need to plug in our 1 and 3 and subtract. And actually it's a little bit easier to factor our 2/3 out of the subtraction, because remember we're going to plug in 3 for u, plug in 1 for u, and subtract. So this will have a 2/3 with the 3 in there and a 2/3 with the 1 in there. So we can factor 2/3 out of the subtraction. So this will then be 2/3 on the outside, and then we can just do u to the 3/2 evaluated from 1 to 3. So that would be a little bit easier. So we got 2/3 on the outside. Go ahead and plug our 3 in. So we got 3 to the 3/2. And then minus, plug our 1 in. 1 to the 3/2 is just 1. And there we've got an exact numerical answer. And we could simplify this if we wanted to, 3/2 power, that's 1.5. So remember here that this is, this is going to be the 3rd power and the square root. So this is square root of 3 and then cube it, which is going to be root 3 times root 3 times root 3. And then these guys together, square root of 9, make a 3. So this is 3 root 3. So we could do a little bit more simplifying if we wanted to. So moral of the story, you want to pick, there may be more than one u substitution. You want to pick the one that simplifies your integral the most.